All right, video number 2, we are picking up right where we left off with problem number 8. It says, write the quadratic in vertex form. Oh boy, have we seen this before. So step 1, to complete the square, divide everything through by your a term. So I'm going to end up with f of x over 2 equals x squared plus 8x minus 4. Next thing, move your constant to the other side. So f of x over 2 plus 4 is equal to x squared plus 8x. Step 3, the fun part, we're going to complete the square. So I'm going to take half of my b value and square it. So that becomes 4 squared is 16. So I'm going to add 16 on this side, which means I add 16 on this side. Cleaning stuff up a little bit, I have f of x over 2 plus 20 is going to equal, this side is going to factor into x plus 4, because that's the number that I squared. You also could just look at this and say multiplying to 16 and adding to 8 is going to be x plus 4 and x plus 4. Last step then is to get f of x by itself. So I'm going to say f of x over 2 is equal to x plus 4 squared minus 20. Multiplying everything through by 2 to get my final answer, I should end up with f of x equals 2 times this first term of x plus 4 squared minus 2 times 20, which is negative 40. Again, I think there might be a small mistake on the original key. We should have that 2 that's multiplied back in, because when you divide out, when you are writing in vertex form, you don't lose the 2. When you divide out, when you're solving by completing the square, the 2 can go away because it's not going to impact your zeros, but it does impact the vertical stretch or shrink of this parabola. How many times have you seen this? Good. Hopefully you said many. So hopefully you can predict that this is going to be a super important topic as we continue to move forward in this course. All right, solve for x. Write your answer in interval notation. An indication that you need interval notation, other than the fact that it says, well, interval notation, is that we are solving inequalities. Inequalities. So instead of having a final answer of x equals, we're going to have intervals where any number between this and this could fulfill this inequality. So to start, I like to read from the denominator right away that I have a critical number that x cannot be equal to negative 2 because that's from the denominator. But then I also need to go through and I need to solve this as if it were an equation. So I'm going to say x plus 12 over x plus 2 minus 3 is greater than or equal to 0. I'm going to find a common denominator to be able to add these things together. So x plus 12 minus 3x minus 6 all over x plus 2. So now I get x minus 3x is negative 2x, 12 minus 6 is 6 over that x plus 2. So again, negative 2 came from the denominator. I also then need to consider where is the numerator equal to 0. That's going to be when x is equal to 3. So I get critical numbers of negative 2 and 3. The negative 2 is definitely an open circle because that came from the denominator. Okay, we can never be equal to negative 2 for this equation because, or this inequality, because we would end up dividing by 0. The 3 though, this says I can be equal to, in which case this 3 that caused the 0, that's okay to be equal to that dot. Next thing, I'm going to test some numbers. So for instance, if I pick negative 3, and I plug it into, I'm going to plug it into here. I'm going to get negative 2 times negative 3 is positive 6 plus 6 is 12 over a negative. That results in a negative answer. Number between negative 2 and 3, I'm going to pick 0. Plug in 0, you get 6 over 2, which is positive. Pick a number greater than 3, I'm going to pick 4. I would get negative 8 plus 6, which is negative, over a positive, so overall negative. This said I was supposed to find answers that were greater than or equal to 0. Positive numbers are greater than or equal to 0, so I'm looking at negative 2 to 3. All right, it's another one. Again, from the very beginning, I like to look at this and just say I have a critical number when x is 2, because that's when the bottom is equal to 2, or bottom is equal to 0. Next thing then, you want to temporarily pretend that this is an equation, so you're going to isolate your terms on one side, already done. Next thing then, I'm going to factor the top. I can take out an x. So from the top part, if I set this equal to 0, I'm going to get x equals 0 and x equals negative 1/6. So x equals 0, x equals negative 1/6. These are the things that need to go on my number line. I don't know why I made that number line so big, but I did, so take it for what it is. Negative 1/6, 0, and 2. Now 0 and negative 1/6 came from the numerator, and it was okay to be equal to 0, so those will get filled in. 2 came from my denominator, so it will never be okay to plug in 2. Next thing then, I'm going to pick some values. Pick a number less than negative 6. We'll go with negative 10. Negative 10 times negative 61 makes positive, but then over a negative, this is going to come out negative. Ooh, a number between 0 and negative 1/6. I'm going to go with negative 1/12. And I'm going to do a little math magic in my head, but I'm also going to say you could plug it in with your calculator. If you picked negative 1/12, which is smaller, you will end up with a positive interval. A number between 0 and 2. I'm going to go with number 1. 1 times 7 is positive over a negative, results in a negative value. And a number greater than 2, I'm going to go with 7. 7 times 43, definitely positive, over 5, still positive. All right, and my original inequality stated I wanted things less than or equal to 0. Well, intervals that would be less than or equal to 0 are the ones that are negative. So negative infinity until negative 1/6, and I'm going to include that. And then I'm going to skip from 0 until 2, don't include the 2. Notice that with this equal to bar, I made sure that I included anything that was filled in dots because those are things that make the inequality equal to 0. So just like polynomial inequalities, except you have to consider where the denominator is equal to 0, in which case you have some open circles on there, even if you're talking about a greater than or equal to inequality. All right, find all of the zeros of the polynomial and write in factored linear form. Well, the first thing you want to establish is the fact that you have 4 answers that you are looking for because of that degree of x to the 4th. So starting with x to the 4th, you could list out all of your potential zeros with the factors of 72 and the factors of 1. But ultimately, you're going to end up needing to graph in order to find one that works to get started. So let's go ahead and see what we got here. So y equals, bring my calculator to this side, clear that out. We've got x to the 4th plus 2x to the 3rd plus x squared plus 18x minus 72. I'm going to do a little zoom 6, get me into a standard viewing window. All right, looks like I get negative 4 as a good root and 2. Negative 4, 2, negative 4, 2. I can check that with my table. Negative 4 was a 0, 2 was a 0. Okay, so you want to make sure that you are exact. So negative 4 and 2. So these came from my calculator, which is okay. So what I'm going to do then is I'm going to put negative 4 in the synthetic box, and I'm going to divide out 1, 2, 1, 18, negative 72. Bring down the 1, negative 4, negative 2, 8, 9, negative 36, negative 18, 72, cancels, boom, yes. Remainder of 0, as it should be. From here then, you've got 2 options. If you look at this, what you really have is x to the 3rd minus 2x squared plus 9x minus 18, which you could factor with some grouping. But you know the next real 0 that's going to come out is 2. So I just like to continue with my synthetic division. 1, 2, 0, 0, 9, 18. Wow, cancels again. Which means that's what is left over. If I started at x to the 4th, I divided out to x to the 3rd, now I'm at x to the 2nd. So this is x squared plus 9 is equal to 0, which means that x equals plus or minus 3i. So there are your other 2 roots. They were imaginary, which is why we didn't see them. Sometimes you'll see them on your calculator, but they're crazy decimals because they are irrational roots. But this time we have imaginary roots. Then it says to write in factored linear form. So factored linear form, I'm going to take these zeros, and I'm going to write x plus 4 because that's the factor, x minus 2 as a factor, x minus 3i, and x plus 3i. So this is your factored linear form. All right, the unit circle. Find the exact value, no decimals, of each trig function. So if we think about the unit circle, we have the coordinate x comma y along the outer edge, which stands for cosine of theta comma sine of theta. You can remember that because x comes before y in the alphabet and c comes before s in the alphabet. So the sine of pi over 6, you're going to look at that coordinate at pi over 6. Hopefully you have a unit circle nearby. And sine is y, so I'm going to take the 1/2. Cosine of pi over 4, cosine is x. We're in the first quadrant, positive square root of 2 over 2. Sine is y. 4 pi over 3 is in the third quadrant, so I'm going to end up with a negative, and that's going to be negative root 3 over 2. Cosine of pi is going to be the x value at pi. Pi is at 180, so all the way to the left of your circle, we're looking at a negative 1. Cosine of pi over 6 is the x value, so the corresponding part that went with the 1/2 for that one is the square root of 3 over 2. 5 pi over 3 with cosine, looking for the x value. 5 pi over 3 is in the fourth quadrant. Cosine is going to be positive. We're looking at a positive 1/2. Sine of 11 pi over 6. 11 pi over 6 is in the fourth quadrant. I'm looking for the y value, which should end up being a negative. It's a reference angle of pi over 6, so negative 1/2 because it's a short distance. Uh-oh, my computer's not writing. Should be negative 1/2. The last one, the sine of pi over 2. Pi over 2 is at the top of your circle. You're looking for a y value. Top of your circle, the y value is 1. I'm sorry those last ones didn't write, but I'd have to restart my whole computer, and I'm about to stop this video anyway, so hopefully remember for letter F, negative 1/2. For letter H, we're talking about positive 1. For your unit circle, you do need to remember cosine comma sine, but you will get the unit circle on your cumulative test, okay? Hopefully it's still in your memory somewhere, but if not, you do have it to reference.